Hello, Algebra 2. Hope you guys are having a fantabulous day. Today is actually a side note lesson. So we haven't really done that before, but basically it's like, hey, this is something you need, but it's not necessarily in the book, and maybe you don't remember it from Algebra 1. So I'm kind of teaching it to you as a side note, hence the side note. Haha, get it? Yeah. All right, so anyways, I know we kind of already talked about functions a bit earlier, but we're going to um, really get a little bit deeper into that. So, what is a function? So our SWABAT today is to understand how a function works, determine what domain and range are of a function, graph functions, and then evaluate functions. So, number one, what is a function? So officially, a function is it's kind of like an equation, but what's special about the equation is that you can only have one output for every input. Okay, so for example, say my function, the machine is like a nice little analogy, nice little metaphor for the function. So basically, you can think of it like this. What if my function machine was one that I input movie titles into, so that goes in the input, and then out comes whatever the first letter is of the movie title. Okay, so for example, if I put in How to Train Your Dragon, it goes through the function machine, bloop, 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 and out pops the first letter of the movie, H, right? Similarly, if your input was Guardians of the Galaxy, your output would be G because the movie title starts with a G. Simple enough, right? You just follow the rule. Okay, so your domain is a fancy name for all the input, all possible input, okay? And then your range is the fancy name for all possible output. So in this case, your domain is all movie titles, right? And then your range is probably like all the letters of the alphabet plus numbers. I don't know. Do movie titles start with numbers? Although the rule is letter that the title starts with. So even if it starts with a number, we'll probably go with the first letter. Anyways, I'm overthinking the function thing too much. But anyways, domain is all titles of movies. Range is letters of the alphabet, right? Because those are all the possible things that you could come up with. All right, so how does this relate to algebra? Well, usually the rules for functions are something like take the input, square it, and then add 5 to it, or something like that. And so often the way we represent that is like so. For example, right? We usually use f of x because f is a function, but you could also have g of x or h of x, etc. Oh, can't see that. Okay, but here's the problem. Okay, a lot of times people multiply the x to the function, which is not the case, right? This is f of x, which means a function of x, where x is your input and f of x is your output. Typically, that's y, right? So there you go. X is the input, f of x is the output. Okay, so in this example, right, it says we want to take the input, which is x, and we want to square it and add 5 to it. So typically we'd write that as f of x equals x squared and then plus 5, right? My input was x, and here I squared it, and then I added 5 to it. Okay, so there you have it. That is kind of your what a function is. Okay, sometimes people get confused when the problem says evaluate, and basically all it means is figure out what the function equals when x is that number. So in this case, right, we have a function f of x, which is 2x squared minus 4, and then it says evaluate f of 0, and basically all that means is, hey, when x is 0, what's f of x? All right, so f of 0 then is 2 times, and then you replace, anywhere you see an x, you replace with 0 minus 4. So you end up with 2 times 0 squared minus 4, which is 0 minus 4. F of 0 equals negative 4. I'll rewrite that so it looks nicer for you. All right, next problem is f of negative 2. So again, you take the function f of x and you just plug in negative 2 anywhere you saw an x. So instead of having 2x squared minus 4, we have 2 times negative 2 squared minus 4. Remember, right now we're just going back to that original function. So then you just simplify it, right? Negative 2 squared is 4, positive 4, times 2, don't forget PEMDAS / GERMDAS, whatever you learned, minus 4. So then you have 8 minus 4, which is 4. Again, I'll rewrite it for you because that's really ugly, sorry. So you can go ahead and pause this and try the next few. Even if there are variables thrown in there, you still just replace them and simplify. You replace x with whatever the variable is and then simplify. I'm going to explain a few of them, but for the most part I'm just going to write out the solution, and then if you have questions on it, make sure you like highlight it or star it or something, and then you can come in tomorrow and ask me questions on it. Right, the third one, the answer is 14. Check my work. This next one is the first one with a variable, so I thought I'd just kind of explain that one to you guys real quick. But basically, right, anywhere you saw an x before, now you replace with an a. So it seems stupid, it seems really silly to do this, but you just change the x to an a, right? So you have 2 times a squared minus 4. So instead of having 2x squared, you have 2a squared minus 4. Okay. Now the one to the right of that, f of x plus 4, this, right? I can take my original function, f of x, which is 2x squared minus 4, and then I just want to, at the end of that, right, because that's f of x, I want to add 4 to it, and then simplify. 2x squared minus 4 plus 4 is just 2x squared. All right, so go ahead, check your answers. I'll leave this up for about 10 seconds so you can pause it and check or whatever you need to do. Again, circle any that you can't follow my work or you're confused about a step or whatever, and let me know in class tomorrow. All right, what if we want to graph them? Okay, so typically, right, you won't be given this fancy function machine looking thing, but you'll be given the actual function itself. And what I like to do is I like to have an input and an output, and I usually call this x, and I usually call this either f of x or y, and I actually include what the function is so that I have it as a reference. So in this case it's 2x plus 4. And so I pick values of x. I like to pick smart values of x. So like, for example, say there's a 1/2 x in it, right? I don't really like fractions, so I might choose x's that are even so that I don't have to like do any decimals or fractions or anything. But you can choose whichever x values you want. So in this case, 2x plus 4 is my function. I don't have any major concerns, so I'm just going to pick a couple numbers around 0, a couple negative, a couple positive, and then just plot those points, right? So my input, I'm going to pick like, I don't know, -2, -1, 0, 1, and 2. And so then I can just plug those into the function. So f of -2 is 2 times -2 plus 4. Well, that ends up being 0, right? Because 2 times -2 plus 4 is -4 plus 4. Okay, next. If I plug in a -1, I've got 2 times -1 plus 4. Well, that's -2 plus 4, positive 2. If I plug in 0, I get 2 times 0, which is 0, plus 4, that's 4. Plug in 1, 6. Plug in 2, and I get 8. Now, if you're confused about that, actually plug it in yourself, figure it out. It's really not that bad. If you're confused, you're probably overthinking it. Okay, so don't overthink it. You're just plugging in x, figuring out what y is. Okay? So then you can just plot those points. So I'm going to plot the point -2, 0 is right. Actually, I'm going to use a big dot. Okay, -2, 0, -1, 2, 0, 4, 1, 6, and 2, 8 is kind of off my map right now. And there's my function. Bam! And it's really helpful if you label it. I'm going to label this f of x is 2x plus 4. We like labeling everything, just an FYI. Next question, what are the domain and range? Okay, the domain is all your possible x values. Now, in this case, you don't have any problem areas. Like, you don't have a fraction, so you can't get 0 in a denominator. You don't have a square root, so you're not going to have any problem with taking square roots of negative numbers. So basically, in this case, you can plug in any value of x and be okay. And if you look along the x-axis, and I start from negative infinity, and I look along the x-axis, imagine you're like a little person walking along the x-axis, right? And moving along that direction. Basically, your domain is, hey, where do you see function if you look up and down and to the side? Do you see a function somewhere? And if that answer is, yes, I see a function at negative infinity and at positive infinity, and there's no problems anywhere else, then your domain would be negative infinity to infinity, or all real numbers. Notation. Okay, for interval notation, which is what the first one is called, you have soft parentheses, because basically, right, a soft parentheses means you can never actually equal that number. And you can never actually equal infinity, so you just keep getting closer and closer to infinity, but you never actually reach it. So you use soft parentheses instead of brackets, which look like that. That would mean it includes infinity, but we can't include infinity because infinity doesn't exist. Anyways, range, you're looking at all the possible y values. So if we go back to our graph, right, imagine instead of being a person walking along the x-axis, you're like a cute little birdie or bee or something, I don't know. And you start down at negative infinity and you float all the way up to positive infinity. And as you're looking over at the function, where do you see a function? Where is there a function that exists from negative infinity to positive infinity? And in this case, anywhere I look, I will see a function exist, right? So again, negative infinity to infinity for the range. Next problem is just a different function, x squared minus 5. So I'm going to fill in the chart and graph it so you guys can pause it, try it on your own, and then I'll talk about the domain and range. All right, this is what this function looks like. So if we were to look at domain and range of this function, right, remember domain, you're like a dude or dudette walking from negative infinity all the way to positive infinity. Right, so he's do. And if he looks up and down, does he see a function? Yes, no, maybe so. Yeah, pretty much anywhere that he goes, he'll see a function either above him or below him. So again, domain is negative infinity to positive infinity. And that makes sense, right? Because I can plug anything in to this function. There's no problem areas. As far as range is concerned, yep, you're a little guy like floating up from negative infinity. The problem is, at the bottom, he doesn't see anything. Like, he can look as far as the eye can see, but can't see any function at all until he hits -5. And then all of a sudden, we go -5, and then he continues to see graph all the way up to positive infinity. So in this case, the range is from -5 all the way to positive infinity. -5 is included, so we need to use a closed bracket, not a soft parentheses. Why don't you go ahead, pause, try these next 3 problems, find the domain and range, and then check your answer. Go. All right, there are your solutions. Hope you did well. Circle any you have questions on. We'll talk about them in class. Have a great night, or day, or morning, whatever.